I request everyone to mute their mic. Hello, Ashraf Ali. Ashraf Ali, you can turn off your camera. As well as you can mute.
मैं आपको इनविटेशन भी तो भाई का अभी तो बताओ कौन करेगा
Hello. Hello.
Yeah, hi, hello.
Yeah. Hi, sir. So I just request everyone to mute their mic, except Sanjay, sir.
Yeah.
Yeah. Yeah. So I think we are good to go, and we can start the session, sir. And I think most of the participants have joined. So while the session, if anyone has joined, then they can start at the same time. So Sanjay, sir, we can start the session.
Okay. Hope I'm audible.
Yes, yes, you are, sir.
My screen is shared.
Yes, it's visible here.
Yes, sir. Visible, sir.
Yes, you can mute and let's start. So my name is Sanjay. So I have 6 years of experience. My education background is MBE in mechanical engineering, MTech in design engineering, and MBA in project management. So achievement wise, I was the university topper. I have qualified GATE and I have like 30 plus national level prizes in the various technical events plus 100 plus prizes in the various cultural events. So my domain expertise are crash analysis and durability analysis. So let's move on. So what you can read on the screen is industrial applications of the finite element analysis. So why particularly this topic has been chosen, there is the big reason behind it. Nowadays, if we see or if we hear, we are hearing so many news that many of the mechanical engineers are leaving their jobs who have 2 to 3 years of experience and they are moving into IT sector since the IT is paying good or the gradually or admissions for the mechanical engineers are reducing, like saying that there are no jobs in the for the mechanical engineers. It's absolutely wrong. Being working in an industry, I can say that absolutely it's wrong. There are multiple jobs in the industry, but that there is the gap between the industry and the the students coming out of the college. So that gap has to be filled. Unlike in like IT, how it happens, just they'll do the course of 2 to 3 months and they'll get the job. So many of the mechanical engineers are moving there, but the future will be really dangerous. So the mechanical engineers who are really proud of being a mechanical engineer and who are passionate about contributing something really towards the world regarding developing new trends in the mechanical engineering, definitely they can work for the mechanical engineering field and really there is a good scope. So to fill the gap between the industry and the students coming from the academics, so academics and industrial gap can be filled by having a proper knowledge and in terms of design, practical finite element analysis is one of the domain where we can have a really good career. So the topic has been chosen like industrial applications of finite element analysis. So we'll go further, but one small note I would like to give. Anyone, if they have any queries, they can type in the chat box, or at the end of the session, we can take it for 10 to 15 minutes, a question and answers. So going further, so while going through our today's presentation, let's have an overview over the contents. So the contents goes as follows: introduction, like theory of finite element analysis, like types of finite element analysis, industrial applications, then what will be the course content when we take up the course, like a further course, then followed by the conclusion. So what exactly it is finite element analysis? So finite element analysis is a numerical method for predicting how a product reacts to real world forces, vibration, heat flow, and another physical effects. Element analysis shows whether a product will break, wear out, or work the way it's outlined like a process. We go through the various cycles. Okay, so design and development is one of the cycle when the product gets developed. So when the product hello.
Hello? Hello?
Hello.
Hello? Yes, Sanjay sir.
Hello, sir.
Hello? Am I audible, guys?
Yes, sir. Audible, sir.
Sanjay sir, your voice is not audible.
Hello.
Hello?
Hello, sir. Audible, sir.
Hello.
Yes. Great. So, Sanjay sir, you are audible, but I hope you are not able to hear us. I think, guys, there is some glitch. Yeah, hello. Am I audible, sir?
Yeah, I have rejoined it. Hello.
Hello, you are audible, sir.
Yeah, I have rejoined it. I guess there was something problem. So I'm resharing my screen.
Yeah, no problem, sir.
Yes, it's is the screen
Yeah, it's
visible?
visible. Yes, it's visible, sir.
Yeah. So if there is something problem occurs, I'll disconnect and I'll rejoin. Please, sorry for that. Okay.
Yeah, no problem.
Yes. So any product when any product gets developed, it has to be tested. When we develop any product, there will be certain objectives while developing that product. That this product has to be function in a particular way. So for that, how should be the design that we need to validate that. So when the small products are there, we can validate it. I mean, we can have a experimental test on it, and then we can see. Suppose now one product is there. Now we can take the example of stool only. On that, I have to design the stool. Then one stool I can manufacture, and then I can apply the load on it. I can make the person to sit on it, and I will see whether the legs of the stool are bearing the force of the man or no. Is it bearable or no? That experimentally I can validate, because the cost of the stool is not much high, that I can manufacture and I can test over it. Otherwise, I can go with the numerical calculation also. The area of the stool I know, that is if the square stool is there or the circular stool is there, area is known, force can be applied and the stresses can be calculated. So this can be happen with the small components or whose geometry is very simple. But what happens if there is like something like complicated shapes? Now you can see here this is the whole car. Now whole car I cannot have any calculation on the entire car, because the geometry or design of the car is so complex that I cannot have the direct formulas to calculate the force, displacement or the various factors on the car. So the simplified model of the car has to be prepared, which is not possible, otherwise it will not give the correct results. And every now and then, for a small changes, I cannot have a test on the car. Like, I mean, for full car, if the non-destructive test is there, that is okay, that we can carry on the car. But if there are destructive, like this one, destructive tests like the crash analysis and that all, what we can see here. So crash analysis and that all. So every now and then, for a small change of design, we cannot have crash analysis. So this everything has to be simulated in the software, and so the tool used for that, it is finite element analysis. So where we divide the known geometry into the small components, like we can see in the second image, that is called meshing. and then we apply the proper physics for that, so that the physics will be in terms of material, in terms of forces, in terms of connections. That is, in short, what I want to say is that how the real car behaves, the model what I'm preparing in my software, it has to be also behave in the same way when we do the actual test at the end. So defining the proper physics is very much important. So this all technique, like dividing the complex geometry into the smaller geometry, known shapes, and applying forces and calculating and applying forces, giving materials, giving proper constraints, and calculating the proper results, what output we are expecting. So this all techniques is called as finite element analysis. So this is just an introduction. In detail, we'll see in our like further full-time course. Okay, so in the product development process, it is used to predict what's going to happen when the product is used. That's what I wanted to say, is that when the product gets, like suppose in this car, now we can see that the bumper of the car is failing, the wheel it is coming out, right? So if this is the this wheel and this bumper, whether it is properly designed or no in the mid cycle, then we cannot have the actual product. So the product has to be manufactured, a product has to get ready, it has to be designed in the software itself. Then we have to have a test on it, and then we have to see whether that product is capable of bearing that much forces, or whether it is designed, or whether it is working as per its function or no, right? So this all can be done with the help of FEA. So much of the cost saving can be done with the help of this. So this is the brief about FEA. Now, why FEA? Why finite element analysis only? Now see, as I said, there are different types of solving problems. Like one is by carrying the experiments, or another is by carrying the simulations, that is the numerical simulations what we are using. Another it is like just by solving solving by known mathematical formulas. Okay. So that's what the first statement shows, that when the problem or structure is simple, solution or calculations can be get you. I request to mute the mic. Calculations can be get using manual calculations through either strength of materials or theory of elasticity. Now, in engineering, you might have studied different subjects to calculate the failure. So the failure of the part can be predicted through the fracture mechanics if we define everything correct. So still if we simplify, then with the help of theory of plasticity, still if we simplify with the theory of elasticity, still if we simplify the problem with the strength of material, we can predict the failure. But that is not the actual failure, since lot of assumptions are made while using these all formulas of strength of materials, theory of elasticity, plasticity, and the fracture mechanics. So these small assumptions or small errors in that may lead to a big problem when we calculate with the hand calculations. So the hand calculations are not so accurate for the complex design, so we cannot use that. So many of the real-time applications involve cases using complex shape, boundary conditions, and material behavior. Now if we see here, two images I have shown at the bottom. Just a minute, let me minimize this. Okay, so I have shown the two images at the bottom. The first one, it is like cantilever beam. So if I tell you to calculate the deflections and the stresses in this, it can be calculated very easily, since we know the geometry and the material is very easy. But the second image, if you see, right, so here the geometry, it is too complex and there are multiple components into it. All will be having different materials, there will are different connections into it, and their behavior is different. Few components may be in the motion and that all. So for that all, we cannot have the normal calculations and we cannot have an accurate result on a smaller component, whether it is passing or failing. So this technique of calculation by the hand calculation cannot be used for the complex geometry. So this gap has to be filled by the numerical methods. So there are various numerical methods computational fluid dynamics that is used. That is more related to the thermal, and the boundary element method is there, where the only the boundaries is divided, and then the problem can be solved. Then there is called finite difference method. Finite volume method is there, and the one more is finite element analysis, which is best among this all. Best and means very easy to handle it. So finite element analysis is required. Yes. So to predict the performance and behavior of the design, to calculate the safety margin, and to identify the weakness of the design accurately. So when we divide the geometry into the smaller elements, when we apply the accurate physics, and when we see, then we will come to know whether that part is failing or no, whether it is designed to sustain that much load or no, or with what factor of safety that component has to be designed. These all things we can calculate with the help of a finite element analysis, and much of the cost saving can be done, and much of the time saving also can be done with the help of this. And the design will be too much optimum with this. If we go with the experience, now if we see in the industry and that all, nominal industry or the, you can see the most of the parts are over designed just by the experience. The people who have done the ITI and that all, they will be working initial days. So they will not be having so much depth of knowledge of the design and that all. So based on the experience only they will do the product, but that product will be over designed. The factor of safety of that product will be too much high, which is not required at all. So the proper factor of safety to be considered, with the help of that, the much of the cost saving can be done, so the proper optimized design can be achieved. So looking at all these things, finite element analysis is must, and which plays a very important role in designing the components or assemblies or full model, we can say. So going further, now where the finite element analysis plays a very important role and how it is, we will see. Now if there is one problem like in the industry, so how the problem can be solved in a design process, engineering design process, that we'll see. First, the definition of the problem is prepared. Problem is defined. What exactly the objective it is, what are our problems, and what is to be done. Because engineering, if we see, engineering is nothing but making the life easy, that's it. So to make the life easy, we are taking up the problem and we are giving solution for that. That is what engineering it is, to describe in a simplest way. So the first, the problem statement, it is defined. Then next, the information is gathered. Whatever possible information regarding that it is available, that we can take. Certain product, if we have to launch such kind of product, whether they are there in market, or if we have to develop new product, what may be the input required for that. Everything, all possible informations regarding that product should be gathered in the form of input data or raw data. Then with the help of that, and by understanding the physics of it, we need to simplify that problem statement into a mathematical model. So mathematical modeling is very important task, because ultimately everything comes on a mathematics. Like I said, I was explaining about the tree. If you have to determine the failure, you must know the fracture mechanics. To know the fracture mechanics, we must know the theory of plasticity. To know the theory of plasticity, we must know theory of elasticity. To know the theory of elasticity, strength of material is must. For strength of material, the material science is must. For material science, physics is must. And to understand the physics, mathematics is must. So ultimately everything comes from mathematics. So maths plays a very major role in engineering. So we have to define a complex problem into a simplest mathematical model and then generate a multiple solutions on it. Whatever possible solutions are there, we can generate and then we can select a best feasible among them. I mean, I will try. Suppose there are three persons, three people are giving the different solutions. So for all three people are giving, I need to validate which one is best because only one can be implemented. So which one is best? So to judge that or to evaluate that, right? So in finite element analysis tool, the tests are carried out. I mean, the analysis is carried out by defining the actual physics or real time conditions for that boundary force, boundary material, all conditions, and then the problem it is solved. Then it is seen whether if it is passing all the criteria or all the like limiting values. Then the solution it is tested once after manufacturing the physical component also, and then it is implemented. If the finite element analysis only the solution it is failing, I mean if the product is not behaving as it is desired to behave, then we need to give the countermeasures for that. We need to give the design changes for that. So based on these all design changes, the component it is redesigned, it is re-evaluated, and then it is manufactured, tested, and then it is launched. Now, if we take this simple bracket, okay, simple bracket it is there. On this simple bracket, we can see the multiple features. So these multiple feature lines, what the green lines, what I'm showing, right? Those are feature lines. Those will be not there in the earlier stage of the design. Okay, so the bracket will be very simple at the earlier stage of the design. Then where the bracket will be fit, that from there what forces are coming on that, how much stresses or how much the displacements are they are coming, that will be judged, and if they are to reduce that, the countermeasures are taken, and these all features will come. Where we can see the hole somewhere, we can see the beads over here, we can see the one more hole. All holes may not be the mounting holes. Some holes are made to optimize the design. So this where to do, and that all that we will be studying in our detailed course. Exactly. So changing the design is one of the solution. So I mean, to change the design, stiffness plays a very important role. And stiffness, like if we see simple for the bar element, the stiffness can be defined by A by L, right? Where A and L are your geometrical properties, and E is your material properties. So E is Young's modulus. So Young's modulus, if we change, then the deformation it is changed, deflection it is changed. In the deflection it is changed, stresses can be reduced. Okay. So changing the Young's modulus is one of the method to reduce the stresses or to change the displacement, to have a control over displacements. But that is not feasible because only if in the local area if I am getting the displacements high, why should I change the entire components material? So the redesign has to be done locally. So changing material is not at all, I mean not considered in the earlier stages. So the local design has to be done so that the much of the cost can be saved and the proper stiffness can be achieved. So like this the design process it is improved and the product it is launched when it is giving the all the limiting values. Okay. So going further, now how these can be solved? How to trust the software? Whether the software it is, because software for if you give anything input it will give any output, right? But whether that output is right or no, how we come to know? There are some checks. So we will take a very simple thing into this. Now the problem definition what it says that there is a beam where the both ends of the beams are fixed and the load it is applied here like 10 kilonewton at the center it is exactly, and two cross sections have been taken, square cross section and the circular cross section, and we have been told to calculate the deflection and the stresses into it. Okay, so for this beam we know the formula, right? So W is equal, I mean W delta is equal to WL cube divided by 192 EI. So P is nothing but load we know, L is nothing but length of beam we know, E nothing is nothing but Young's modulus is known, and I mean moment of inertia is also known to us. Okay, moment of inertia is calculated from the cross sectional area. Okay, so okay, you must be aware of the formulas and that all. So once if we get the deflection, then the stresses can be calculated by using the like bending equation. Okay, m by I is equal to f by y is equal to e by r. Okay, so using that equation, the bending stresses can be calculated. So here for this, like if we see calculations part, I have not shown. You can make the calculation of it after the session gets over, and then you can compare the results. So with the help of simulations, what results we are getting? So this is like the deflection we are getting into it in the circular cross section, and with the analytical results also, I mean with the help of calculation also, almost 0.03157. So almost the results are totally incorrect because we have defined the accurate physics for it. I mean both sides should be constrained, so degrees of freedom, in all degrees of freedom it should be constrained, and the load is applied in the particular y direction only, and then the stresses are calculated. Okay, so there are different methods to calculate the defining the single problem. So here I have used the 1D elements. So the same problem can be solved with the help of 2D elements, and also the same problem can be solved with the help of 3D elements. So we must know which elements to be used when for the optimum results. Okay, so that again we will be studying in our detailed classes. So which kind of elements, where they have to be used in an entire vehicle or a small subsystems. So now going further, so there are different types of analysis. Now we are coming particular to the FEA. We are skipping the part, I mean we are skipping the calculating the results by the analytical method and by the experimenting method. Now in the FEA, to solve the FEA, I mean again we are coming specific to the, so here just a minute. So here there are different types of analysis I have listed. So let's go through this analysis once. So linear static analysis, non-linear static analysis, dynamic analysis, crash analysis, seating system, full vehicle crash analysis, drop test simulation, NVH, CFD, thermal analysis. So these are just the categories what I have mentioned. This is not the type of analysis exactly. In this there are again, these all fields are too vast. Okay, there are many kinds of analysis into it, so that we will be taking in our further classes. So the analysis, engineering analysis, okay, or when we are applying the mechanical load, how the system behaves. Based on that, the analysis are classified into linear analysis and non-linear analysis. So we know this very standard equation. When we apply the force, the governing equation is like f of x, where x is the function of time. It means f of t, if I have to say, f of t is equal to mx double dot plus cx dot, okay, plus kx. Okay, if we see this equation, all the types of analysis are categories based on this equation only. So the linear analysis and non-linear analysis. In the linear analysis, force versus displacement or the stress versus strain curve is constant. It is not changing. This is linear. And in the non-linear analysis, it is not following the equation of the straight line. Okay. So this is the non-linear analysis. So in the linear analysis, what we can say that again there are types in the linear analysis and non-linear analysis: material non-linearity, geometrical non-linearity, and contact non-linearity. Now, if we take the material non-linearity, in the material linear analysis, the Young's modulus of the material is constant throughout, but in the non-linear analysis, the Young's modulus of the component or Young's modulus of the material is changing everywhere. In short, what I can say that if you have to view the component or if you have to validate the component only in its elastic region, then you can go for the non-linear analysis. And after the elastic region, when it goes into the plastic region, the curve will change, the slope of the curve will change, and the Young's modulus may not be same everywhere. So we can go for the non-linear, material non-linear analysis. So same again, for the linear analysis, most of the static analysis are linear analysis. There are non-linear static analysis too, but that we will talk further. Okay, so this is about material linearity and material non-linearity. So contact linearity and contact non-linearity. If we are taking the contact forces into the picture, then we can say that is contact non-linearity. If we are not taking contact forces into the picture, if we are solving the problem directly with the help of FEA connections only, then it is known as contact linearity. So detailed will be studied again later. So just I am giving the brief idea of it. And one more comes geometrical linearity and geometrical non-linearity. So like how we consider true stress and engineering stress. So similarly, in engineering stress, what happens? Change in geometry is not considered, whereas true stress, the change in geometry at every instant it is considered, and based on that the stresses are calculated and they are summed up, which gives the true stress. So similarly, change in the geometry or change in the stiffness matrix is considered at each interval of time or each increment of time in the nonlinear analysis. So change in the stiffness matrix changes means change in the geometry is occurring. Geometry is changing, so that if we are taking it to consider, then we can say that is geometrical nonlinear analysis, and usually it is considered for the high deformation or severe deformation whenever is there, then the geometrical nonlinearity is considered. And also there are different types of analysis based like explicit analysis and implicit analysis, that is based on the types of mathematics or what we are using to solve the problem. So based on that, implicit and explicit analysis are categories like that. So like this, in the dynamic analysis here, the various modal analysis, frequency response analysis, these will come into the picture. So in the crash analysis, so vehicle crash analysis, there will be the frontal crash, side crash, rear crash. So crash analysis is a huge domain again, and which is very demanding also. And one more like seating system analysis, which is also a part of crash analysis, but which may not be always dynamic analysis in nature. Many of the analysis will be in the quasi-static analysis also. Quasi-static is comes in between static and dynamic. Crash analysis, what I was talking, subsystem wise is also done, and on full vehicle level also crash analysis is done. So drop test simulations, most of the drop test simulations are done on the mobile and many of the white goods where the washing machine, TV, fridge are get manufactured. So there the drop test simulation it is must. NVH, that is noise, vibration, harshness analysis, it is which is also a major domain in the automobile sector. And CFD analysis, computational fluid dynamics, and thermal analysis. These are like the thermal analysis, which I am not much experienced into. And also there are different kinds of analysis which I have not mentioned here, like many durability analysis are there, fatigue analysis, and nonlinear stress analysis too. So those are also the various types of categories of the analysis. So going further, so to solve that, we must have the proper software knowledge. So full vehicle has shown here. So the softwares required as a preprocessor, when it goes through the various stages component. Earlier the CAD design is done in the softwares like ProE, CATIA, Unigraphics or SolidWorks. Then the same CAD is taken into the preprocessors. So preprocessors are generally hypermesh and ANSA preprocessors are used. So where for a specific analysis, what should be the kind of design? What can be the element types? How the meshing should be? and that all detail, which is also a very big domain to study, and which is very must to have the before having the knowledge of solver, we must have the proper knowledge of the preprocessor. So I recommend everyone to study the hypermesh and ANSA or ANSA before going for the any solver, like, yeah. So hypermesh and ANSA are clubbed with the various solvers. I will tell you which are the solvers it is clubbed with. So there, like, hypermesh is a very powerful tool for 2D and 3D meshing. Yeah, and means usually it is used in all automobile sectors, off-highway and aeronautical also. So ANSA is comparatively very fast, but also very expensive tool also. And much of the automations are done in ANSA, which are there also in hypermesh also in the latest versions. But that is left to the person what is to be used. So having the proper knowledge of hypermesh is enough, I guess. With the help of this further softwares we can learn, or the further domain expertise we can go into. So here the meshing it is done. So proper the component material thickness, what are the types of joints, I mean the joints or what type of connections, like spot weld, spring, damper, various joints like knuckle joint, universal joint, spherical joint, revolute, translation joints. These all kinematics and dynamics to be defined here. These all things we do in the preprocessor. And then for when it goes for the solver, there are different solvers like Nastran, Abacus, LS-DYNA, FemFat, Encode, OptiStruct, Radios. There are multiple solvers to use. So which solver it is to be used for which application, that is against different thing. So Nastran mostly it is used for the NVH application. Abacus clubbed with FemFat or Encode it is used for the durability. Or even OptiStruct plus FemFat that can be used. And LS-DYNA, which is nonlinear explicit, is used for nonlinear explicit dynamic analysis. In the here various crash analysis, full vehicle, seating system level analysis, drop test analysis, these all can be carried out in the software called LS-DYNA, where we get the exact results, and provided if we are defining the proper physics, and where we get the, a proper simulation. Properly we can visualize the animation in the LS-DYNA. Okay, so in the Abacus explicit also those things are there, but which is not much handy to use. Then there are different post-processing. Once the solving rate is done, then the results to be viewed. So to view the results, there are different tools like Hyperview or Hypergraph, which comes with the hypermesh only. In the package only it comes Hyperview and Hypergraph. There is the software called LS Prepost, which is attached with LS-DYNA. So it comes with the LS-DYNA. Here we can view all the results. Various graphs can be plotted, and the results has to be interpreted. Animations or animator tool is also there, and there is tool called Meta, which is clubbed again with the preprocessor ANSA. So ANSA and Meta comes with the same package. So in this we can do the post processing. So I recommend initially to go with Hyperview and Hypergraph. Yeah. So Nastran, where the Nastran specifically we can go for the linear and non-linear analysis, but only for the implicit analysis and not explicit. Okay. So these are the softwares introduction I wanted to give of the solvers to solve the problems. Now, there are different simulations have been done. I was focusing on one part again and again in the entire seminar, that is defining the accurate physics. So this is what happens after defining the accurate physics. Now there are three different balls. In the first image you can see there are three different balls. Okay, all are dropped, all are having the different mass, and we know that they should reach at the same timing, provided that the frictional forces you are not considering. Because frictional force is again dependent on the area of contact. So area of contact, if you are ignoring, then all three balls are coming and reaching at the same time. This is the simple physics is evaluated. And here, if you are defining the coefficient of friction for all the three balls, okay, Then based on the frictional properties what has been given, so the which is having very less friction, what we have given the value, that ball will reach first, the which has the next, so tentatively it will reach. So this is what is defining like accurate physics. Now the second is like image shown, which is like the SBA. So SBA is nothing but seat belt anchorage test, which is one of the seating system test. It is done. So which is the quasi-static process where the simulation is done to replicate the actual physical test, and it is evaluated. So which is also carried in the LS dyna. So where all the things we must define the properly. So this is, there are two blocks, one is shoulder block and one is lap block, and the seat belts are there. And this is again complex thing, I mean detailed thing. Just we can come to know when we exactly go into detail into it. Then there is like a drop test here, adjacent to that drop test and packaging. So usually when the product gets manufactured, it is handled from here one place to another, and that all. In that time, the proper possibilities are there that the product can break. So proper packaging is to be done for that, and the strength of the package, and that all that can be evaluated based on the plastic strains and that all. So there are different kinds of drop test: corner drop test, edge drop test, face drop test. So based on that, the proper designing can be done. So then there is called crash analysis. So in the crash analysis, two terms are there: designing the vehicle for the crash worthiness, and designing the vehicle for the safety, occupant safety or passenger safety. So here, so we manufacture our own vehicle. Each OEM will manufacture their own vehicle, and the own vehicle has to be tested in as per the crash regulations. So the crash regulations are like FMVSS, Federal Motor Vehicle Safety Standards, and ECE standards. Also we have some Indian standards. So in which country you have to launch vehicle, in that your particular test should pass. I mean the injuries, forces and that all, what they are coming on the occupant, those should be minimum. So you might have heard about the 5-star rating, 4-star rating for the car, or NCAP, new car assessment program. When you are going for the developing new car, that time it should pass certain criteria. So the injuries on the dummies are calculated. Dummy is nothing but human body development. It is, I mean, actual human body, like human body we develop there. So there will be many sensors into it: force sensors, deflection sensors, moment sensors, and that all. So these all are calculated, and the help of formulas, the HIC, head injury criteria is calculated: thoracic trauma index, chest deflections, rib injuries, lower TBI index. Many things are there which can be calculated. We will be seeing in the animation whether the airbag is deploying properly or no, how much safety we are getting with the help of airbags, how much safety we are getting with the help of seat belts. Okay, and there are other safety parameters also. So how they are helping, and how our vehicle should be designed. So designing vehicle is not like only from the outside. Each parameter or each component, how it should like function, that all we will be checking, because vehicle is like manufactured with the help of almost more than thousands or lakhs of parts, or screws, nuts, bolts, belts, spring, masses, dampers, etc. So yeah, so to study all this, we must have the proper knowledge of hypermesh, which is the pre-processing tool, or we can choose the one of the domain like crash analysis or durability analysis, and in that we can go study this in detail. So where we will be also seeing the actually, how the mathematical modeling of the problem it is done, how the physical problem will be converted into the mathematical problem, or how the real world problem is converted into the physics problem. So these all small things we will see, and then we can go for the actual big crash test and that all that can be studied. So this is the brief like industrial applications of the finite element analysis. can be used. Yeah, this is all what I wanted to say from today's lecture. So thank you so much for attending. So it was quite a brief lecture. I mean, in depth we will see because it is a very vast topic. So in like actual live classes, we will be studying all these things in detail, where we can take up your queries and that all. But yet, if you have any queries and that all, right now we can go for it.
Sir,
Yeah.
hello sir, can you hear me?
Yes, I can hear you.
Okay, sir, I have one question regarding, in ANSYS, there is one software called ANSYS. So in ANSYS, do we all the three stages of APA method is done over there? That is pre-processing, the solution, and the post-processing.
Yes, exactly. So pre-processing, post-processing, and the solution can be done in the ANSYS. So
It's self-program.
yeah, we can do it into the ANSYS, but again, each software has their own limitations. So in the ANSYS, all the crash analysis and that cannot be done into the ANSYS. That much pre-processing capabilities are not there with ANSYS, right? So
Okay,
so certain simulations are possible into the ANSYS, but when you go for such a big analysis and that all, they are not possible, because whatever, like, so see, for the crash analysis and that all, whatever the human body models and that all, what you are required, those are not modeled in the ANSYS. They are not present with ANSYS, right? So you may not get the accurate result. You may not be able to calculate all the injuries into it. Okay. So ANSYS, yeah, it is best software, but it has its own applications or own advantages and own limitations. Yes.
Okay, so what type of analysis we can perform in ANSYS, like linear, non-linear, or something?
Yes, linear static model analysis, frequency response analysis, heat transfer analysis. So these all can be done into the ANSYS. Yes, it is possible.
Even I think we can do the CFD part also. That in ANSYS student, I think we sometimes perform the CFD analysis,
Yes,
right?
yeah. In ANSYS it is possible, but again for the ANSYS it is common package. But for the CFD, I recommend to go for the Star CCM. So Star CCM is the best software specially designed for the CFD, where the accuracy of the result is too high.
Okay, sir. And one last thing I want to know from you, that before learning all these softwares like ANSYS, Workbench, or Fluent, so is it better to have in-depth knowledge about FEM or CFD or something in the theoretical knowledge? Is it important to have the theoretical knowledge first?
Yes. See, I recommend especially theoretical knowledge is must at all, because we are engineers. We are not the software users, right? Software can be learned by anyone. Like suppose, see, talking about hypermesh or something, I will talk about myself. If you give me any non-technical person also, I will make him to understand what exactly the mechanical engineer it is. Right? Or I mean, how the software works, I can teach him. Or software is nothing but which options are where. But to design the model, okay, or to give the engineering judgment when you are getting the results, so you must have the proper knowledge of theoretical. Your basics, fundamentals should be very clear. Then only you can able to get the problem. Otherwise, it is just giving the solutions. I say right in the earlier problem. Software, if you give any input, it will give you output, but you must know what output it is giving, whether it is reliable or no, right? So to know that,
for that we need to have the basics first.
Yes, basics are must everywhere.
So suppose if
okay, carry on.
so if anyone wants to pursue career in this field, like computational aided engineering, so first of all he or she should know the complete theoretical knowledge of suppose APA or CFD, and then it's better to jump into the software, right?
It is not only FEA I am talking about. FEA knowledge will come when you learn along with the software, it will come knowledge of FEA, right? but you must have your the strength of materials, design, physics, strength of materials, material science. These all basic should be required. See, if you want to become a proper good engineer, because you have to take the decision, you should be able to take the ownership of the program. You should not be asking, suppose if you want to go, if you are project engineer for one of the car, to go to manufacture one of the car, then you cannot ask anyone, right? You cannot ask anyone that, here I am stuck, what will be the solution? You are the leader of that program. You need to give the solutions on it. So you should, without having the proper knowledge, we cannot give the solutions for the problems.
Absolutely right. And sir, one last question that if for entering into this field means like APM, so first of all, which are the basic mechanical subjects one has to strengthen, like strength of material and any other subjects, if any?
Yes, strength of material is must. Material science knowledge is little bit is required. And the design of machine elements, some of the basic components, they are required. Yes, basic. Some
theory of machine also.
Not exactly everything is required. So it depends on what kind of industry you are going. Based on that, it is dependent. Having everything knowledge is always good. But it is not like that. All the coursework what we have learned in our academics, everything we must know. It is not like that. It will come with a proper mentor or proper guidance. You will get to know that. Yeah, thank you.
Okay.
So can we go to the next question? Yeah,
okay, sir. That's all with her.
Yeah, good evening, sir. Yes, sir. Good evening, sir. Yes, please. Yeah, okay, question.
What kind of software is recommended for analyzing the centrifugal bands? Centrifugal band is using for textile engineering for to delivering the volume of air. How much volume of air is required to deliver or suction the bluff dust bluff is suction from friction machinery. Or what kind of?
See, this all can be done into the CFD, computational fluid dynamics.
Okay.
So you can go for the as per I said, this can be done in the ANSYS also, and also with the help of the CCM software also it can be solved.
Okay. Thank you, sir. Thank you very much. It is easy to machine. Hypermesh is help to machine the element.
Yeah, hypermesh you can use for the meshing, but when you take the hypermesh elements into the ANSYS, proper conversion of the elements has to be done. Yeah.
Okay.
So that has to be done. So element types with the hypermesh and element type with the ANSYS, they are different. So they have to be converted properly. So that care has to be taken.
Okay, so the neutral software is step conversion support, possible to support other.
So I did not get you what you want to ask. Sorry, can you repeat?
Okay. No issues. There is a neutral file is there, sir. The neutral file is step 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 file is there. That file is can possible to support to analyzing the CFD, sir.
No, that is CAD file, right? Step file is CAD file, right? So CAD file has to be converted into FEA, right? First.
Okay.
Yeah.
Is can possible to do on CAD or Pro or the SolidWorks which model?
No. These SolidWorks CAD, those are CAD software, right? So in that you cannot analyze CAD. Only you can prepare your design. CAD you can design, but all designing factors you cannot evaluate on it, right? So for that the solver is must, like what I said.
Sir, I want to know the neutral file type for conversion of modeling from CAD to ANSYS or CAD to some other.
That question separately we can discuss again detail. Okay.
Thank you, sir.
You can chat, put it into the chat box. Okay, we will study it. Okay, and you can mention your contact number out there. Yes, Ashraf Ali.
Thank you, sir.
Yeah, Ashraf Ali. Hello. Yeah. Sir, if we want to get in with this software, so we have so which is the first software we have to we have to get in.
See, that depends where you want to go. I mean, where you want to go. What is your target? Where you want to go? What is your interest? Right? So, see, if you want to become a design engineer, you can CAD engineer, then you have to go for CAD software. If you want to be an analyst, so Hypermesh is the must software what I can prefer, like Hypermesh, because Hypermesh is clubbed with, you can mute yourself if your question is done. So Hypermesh is the basic software, and the Hypermesh it is clubbed with the software like Abacus and Abacus, Masterplan, OptiStruct, Pancrash, LS-Dyna. Many with the software it is clubbed. Once it's the Hypermesh pre-processing, because much of the part is done in the pre-processing only, and then the solver is just used for the solving, right? So all these things can be done in the Hypermesh. So I recommend to learn Hypermesh first, and with the help of Hypermesh again linear analysis. Go for the linear analysis and then go for the non-linear analysis. Because I especially don't recommend to go for the non-linear analysis or dynamic analysis directly, because unless and until linear and static analysis fundamentals are correct, so the dynamic and non-linear analysis is difficult to grasp or difficult to evaluate, interpret. That is answer for your question.
Thank you, sir. Sir, one more question. Sir, we have to learn step by step, like one thought, like Hypermesh, and then we have to go for Crash.
Yes, then yeah, you can mute yourself and tell you. See, there are three domains basically into the design engineering, that is durability, NVH and crash. So it depends on the interest, where you want to go. In the durability analysis, as I said, the fatigue analysis are carried out. So that is not just the only fatigue analysis. There are multiple kinds of analysis. It is a very vast field. So these are done. And in the NVH, noise vibration harshness, modal analysis, FRF analysis, random vibration analysis are done. In the automotive sector I'm talking about, and in the other sectors also. And in the crash analysis, LS-Dyna you can go for it. So if you want to go for NVH, you can go for the Masterplan. For the durability, you can go for the OptiStruct, Abacus, and FemFat or Encode. And for the crash analysis, LS-Dyna, you can go for it. But for that, all the things, Hypermesh is the mother software which everyone must know. Yes. Can we go for the next question? Yes, Satish Kumar.
Good evening.
Yeah, good evening, Satish.
Yes, sir. I am working at behalf of biomaterials. Let me know which are the responsible for biomaterial analysis.
Biomaterial. Exactly, may I know what you are into it? Biomaterial, what you are doing?
Kipcha.
Huh?
Kipcha.
See, it is developing about materials only, then LS-Dyna I recommend, because even we too work in the biomechanics, not biomaterials, biomechanics. Okay, so biomechanics is nothing but developing the human body and that all. So what kind of skin, what kind of tissue materials is to be done. LS-Dyna has a huge material library, so where all the materials are defined, the physics of the materials are defined, and exactly what it is happening that you can evaluate into the LS-Dyna. So I recommend to go for the LS-Dyna for it, to develop the materials. I mean, to use the already developed materials, or even the new material can also be developed, and that can be incorporated into the LS-Dyna, provided you should know a little bit coding knowledge. Yeah.
Thank you.
Anything else?
Nothing.
Yeah.
Sir, if we want training about of this software, so
Hello, am I audible? Like we are coming to it. Actually, we are going to launch a course, like which will cover all this in deep. Okay, that is delivered by Sanjay itself. Okay. So we have already launched the course on our portal, and if you want to register yourself on the same in the same course, you can register. The link is mentioned in the chat box. Okay, and if you register in within 24 hours, you will get a discount in the same. So the cost of the course, the total duration of the course is 20 hours. It will be approximately 20 hours, which we will be coming to, we will be going into the details. Apart from that, the cost of the course is 14.99. So, the contact number here is not possible at all. You have to follow the proper channel. You have to contact the ISIEINDIA to get in touch with the trainer.
Yes. Anyone has any queries still? Hello, yes, Nutan.
Yes, sir. Currently, I'm familiar with CAD software like AutoCAD, SolidWorks, SolidX, also the MasterCam software. So I just wanted to know that before learning FEA, is it necessary to learn another software like previously, something like that? Previously.
Yes, exactly. Because CAD softwares, as I said, they are only used for the designing. So to enter into the analysis, we must have the FEA. Now, as you said, CFD, if you are more interested towards the thermal analysis and that all, then you can go for the CFD and that all. But if you are really interested towards the subject like design of machine elements, DME, design, vibrations, strength of materials, so then you can go for the either abacus or LS dyna, like that. These things we can go for. I mean, Astran, OptiStruct. So hypermesh we must know for all these things, and when we know the hypermesh, with that only we will be able to grasp the other things. Because CAD software is done only to manufacture the CAD, same CAD developed by you is used by the FEA analyst to solve the problem. So having knowledge of the solver is must. Solver and the preprocessor like hypermesh is must. Yeah. Anything else? Vignesh, yes.
Sir, in 1499, how many software we can learn?
That will be answered by this one only, ACS department only. See, one thing that I cannot tell. What I'm telling is softwares are too vast actually. So I don't recommend to. See, learning is how many software is not important, because you are not going to work on all the softwares. We will be working in one domain. So I recommend to go for the hypermesh. Then learn hypermesh is a preprocessor that we have to learn. Then one analysis software like OptiStruct, Astran is used, should be learned for the static analysis and linear analysis. And for the non-linear analysis, we can go for the LS dyna. So like this flow we can keep it. So these three softwares can cover up all the designing softwares. Yeah.
Sir, before joining, can someone give some counseling about the softwares, like which software is best for us, our background? If I have done my diploma in automobile, so which software will be best suitable for me? Like someone will give counseling to us if we join the training.
Yes, that can be done.
Okay, sir, thank you.
Yeah. Yes, anything else? Anyone else?
Apart from hypermesh, which type of software can be used for solving of the FEA analysis?
See again, and coming to the same point, hypermesh is the preprocessor. What I'm saying. So ANSI is one more preprocessor which is linked with one second. Let me open a hypermesh and let me show you. It will take 2 minutes to open it. But that's what just basic GUI of hypermesh I will show you. Is my screen is visible still, or have I shared the screen? Yeah, screen is visible, right? My laptop is a bit slow and it is working a bit slow today. Yeah. So that's what I want to say. Hypermesh is a preprocessor software which is clubbed with the many solvers. Okay. So for that all solver, if we select one solver ls dyna into it, the options in the hypermesh will change. So hypermesh will start working supporting for the ls dyna. If you select the Nastran, the options in the software will change and the cards and that all, then for the Nastran it will show. Right? Like it is opening, it will take 1 minute. Okay.
So hypermesh is used for analysis of FEA systems. So after designing them, either we can go for some CAD design software or some software for basic model design, and then we will be importing it into an hypermesh, and then we will be analyzing the final analysis on stress materials.
Yes, exactly. Yeah, exactly. See. Now focus on the screen. So hope my screen is visible, right? So now when the hypermesh is opened, now it comes the default software. Now default hypermesh is only it will support hypermesh. Only meshing can be done. So Radius, Optistrad, Abacus, Actran, ANSYS, Exodus, LSDANA, Madimo, Mark, Nastran, Pancrash, Burmas, and this is SAMCASE. This I am unaware about it. So these all are the softwares. So if you keep ls dyna, so all the cards inside it will change. Okay. If you select ANSYS, whatever you are defining for ANSYS, what the deck is to be prepared in the hypermesh, that you will turn it here. For Abacus, again, if you click Abacus and if you say OK, then all the options, certain options will change. They will only the supporting options for Abacus will come into the picture. So if you learn hypermesh, then it is learning other things will become so easy. So whatever for LSDANA, whatever it is required to solve it, so that all things we will prepare into the hypermesh. For Abacus, what is required, that all we will be preparing in the hypermesh, like that. Okay, and for this, like CAD it is used. So CAD we will be taking from here, CAD we will be importing, and then the meshing will be done, and then it can be solved further. So this is how it goes.
Okay. So I have another doubt that I am using an system software, system magnet. So from that, is it possible to go for an hypermesh when I am having a design process in that software, and then is it possible to extract to the hypermesh?
I'm unaware of the software what you are using. I don't have knowledge about it, to be frank. That time I have heard about it first time.
Yeah.
Hello, sir. Can you mention the companies which they are using API software?
See, any OEM, if you take OEM, there are different kinds of companies. OEM, tier 1, tier 2, tier 3, and then the service-based companies which are providing services to the OEM. Like if you go anywhere in the India, I will mention few of the cities where there are very really good jobs are available. First one is Pune, Chennai, Hyderabad, Bangalore, and Greater Noida. So these are the 5 cities where the most of the jobs are available into the mechanical engineering, core research and development, what I'm talking about. So there are different OEMs like Tata is there, Ford is there, FCA is there, Fiat Chrysler. So these are talking about only automotive companies. Mahindra is there in India. Then various, and the suppliers are there for seatings. Johnson Control is there, Alient is there, Forestia is there. Many are there, many. I mean, I cannot list all those companies. and for off highway there is John Deere is there, yeah, Levi is there, many other Caterpillar is there. For white goods, LG is there, Whirlpool is there. Okay. So these all are the companies which are there are many companies actually. I cannot name all of them. Okay. Next. Yeah. Who is speaking? Yes, Satish. Yeah, please.
I noticed you are giving the training for software license. Yeah, it is a physical training or online training?
It is online training.
Okay. So how can because I have done to learn the abacus piece. I don't have the software, but how can I get the software?
That everything will be provided to you. I mean, it will be told to you from where to download, what to install, and that all everything will be told to you.
Okay, it's a cracked version, right?
Yes, correct version.
Yeah, sure. Thank you.
Yeah. Yes, and do you have any queries again?
So, I hope we can wind up. We can follow the session and we can follow this thing.
Yes.
Yeah,
Thank you.
Yeah, thank you, sir. Thank you for your time. And it was a nice session. And thank the participants. If you are interested in joining a deep course like the course that we are planning to have, 20 hours of the course, please fill up the form available in the chat box. Thank you, everyone. Over to you.
Yeah, one I would like to tell you that there are the many institutes which use the course and that all, but as I said, the learning the software, it is not only about the learning the software which options are there. So learning proper physics, having proper knowledge, that is also important, how they are correlated to the software. So that will be well taught here. So that is how we are different, what I can say. Because personally talking about myself, as I said earlier, and I have the experience working in the OEMs for the US, German, and also for the India. I have the test experience also, FEA experience. I was the university topper, yes, and also I have trained many IITs too. So this is what we are different than the others. So I request you to join the course. Yeah, that's all from my side. So rest decision is on you. Yeah, thank you. Can we leave the meeting now? Hello. Yeah, you can leave the meeting, guys.
मेरे को नहीं पड़ेगा तेरे को पड़ेगा मुझसे कम घंटा नहीं पड़ेगा मुझसे कम हाँ बिल्कुल पक्की बात है 100% तू होएगा ना भाई तू होएगा मेरे को पता नहीं बैठना होगा तो घंटा नहीं पड़ता क्या तो रहा है तुझे पड़ेगा मुझसे ना मुझे नहीं पड़ेगा तू ही आया दिल्ली में तू कल मंडे को भी तू ही आया क्या तो रहा है क्या करता आप भेजती हो आप भेजती है हाँ बिल्कुल मैं डेडलाइन लिख के भेजूंगा मेल में तो मेरे को ऑलरेडी कहा था मैं नहीं कर सकता मतलब ठीक है ना तो मैं तो कहता हूँ भाई दिक्कत होगी वो बोला नहीं मैं सीधे बोल दूंगा मेरे को काम है या तो काम का लोड कम कर दो मेरे पे क्या पड़ जाएगा सारा कुछ के ले लूँगा पैसे इसके हाँ इसे छोड़ नहीं आऊँगा मैं तो तुम जा रही हो आ गया निकल भाई नीचे खड़ा हो अभी भी अंदर में चल रहा हूँ अंदर में चल रहा हूँ नहीं बैठा अभी हम जाना है 10 बजे मुझे आना है लेकिन हम अभी चल रहा हूँ उधर अभी तो है खत्म हो गया ना तो बड़ा मैंने यार